Good day, viewers. Welcome to today's class. I'm Chioma, your mathematics teacher in Fame Global Academy. So today we are going to be talking about logarithm. But before that, let's do the correction of last class assignments. Okay, so the correction is under indices. Okay, remember last class we did indices, definition of indices, and laws of indices, and we also solved some examples under indices. So let's take the correction of the assignments. So number one question was m raised to the power of 8 divide by m raised to the power of 6. Okay. Number two question is 4 raised to the power of minus 3. And number three question was e raised to the power of 3 raised to the power of 4. Okay, so let's start from number one. You remember in laws of indices, division means subtract the powers. So if the two bases are the same and we have division in between them, you subtract your powers. So this is m, so we have m raised to the power of 8 minus 6. 8 minus 6 because it is division, so you subtract the powers. So 8 minus 6, that will give us m raised to the power of what? 2. So that's the answer to number one question. Then number two, we are having, this is what we call inverse law. When a number is raised to the power of a negative number, the negative turns to inverse. So this minus here will turn to inverse, and inverse means 1 over. So this minus has turned to the inverse of what? 4 raised to the power of 3. Okay, so 1 over 4 raised to the power of 3, that is the same thing as 1 over 4 raised to the power of 3 means 4 times 4 times 4. Okay, 4 times 4 times 4. Okay, so 4 times 4 times 4, that will give us what? 4 times 4, 16. 16 times 4, that will give us 64. So our final answer is 1 over 64. So that's the answer to question 2. Then the last one is e raised to the power of 3 raised to the power of 4. This is an example of a product law. Product law means multiplication. When a number or a letter is raised to the power of 2 powers, one inside the fraction, one inside the bracket, one outside the bracket, all you need to do is multiply the 2 powers, the one inside with the one outside, and that will give us e raised to the power of what? 3 times 4. And that is equals to e raised to the power of 3 times 4 is what? 12. All right, so that is the answer for question 3. All right, so this is the correction for last class assignments. So with this, we have ended the correction, so we'll now go to what we have for today, which is logarithm. Okay, so let's take the definition of logarithm. The logarithm of a number a to a base b is the index written as log a base b is the index to which b is raised to obtain a. Symbolically, comma, if log a base b is equals to c, then it implies that b raised to the power of c is equals to a. All right. So let's look at the definition of logarithm. It said the logarithm of a number a. So this a is representing a number, the b is also representing a number, okay? So the logarithm of a number a to a base b written as this. So if you see something like this log a base b, this is how this is being read. Say log a base b, this is the base and this is the logarithm itself, okay? So that's what we're having here. So the logarithm of a number a to a base b written as log a base b is the index to which b is raised to obtain a. So symbolically, if we have log a base b is equals to c, the index we are talking about is b raised to the power of c, which is the base raised to the power of the answer to give you the logarithm. So that implies b raised to the power of c gives you a, which is the logarithm. Okay, so when we talk about index has to do with a number that has power, like our indices. I said it in our last class. Index means singular, indices means plural. So this is an index form of this, okay? B raised to the power of c is equals to what? A. So this can be read as log a base b. Don't forget that. Log a base b, okay? All right, and this is log a base b is equals to c. So when you have a logarithm that is having an answer, it is the same thing as the base raised to the power of the answer will give you the logarithm, just like what we have here. So this is written as this, or it implies this. Log a base b equals to c implies that b, which is the base, raised to the power of the answer is equals to the logarithm, which is what? A. Okay, so let's look at some laws of logarithm. Let's look at some laws of logarithm. Okay, let me clean this. Okay, so we have laws of logarithm. Number one, we have log x base a plus log y base a is equals to, okay, so this is called addition law. When you have two different logarithms having the same base and is addition, the answer is multiply the two logarithms with the same base. So this will give us log xy. Xy means x times y base a. Log xy base a. This is log x base a, this is log y base a. So long as the two of them are having base a, then you take it as log base a, then multiply the two. So this is called addition law. Addition law. Okay? Now let's look at number two. Number two says if we have log x base a minus log y base a, this will give us log x over y base a. This is called subtraction law. Okay, so just like what we had here, the one of addition, you multiply the two logarithm, but the one of subtraction, you divide the two logarithm. So long as they are having the same base, you can see this base a, this base a. Okay, so subtraction means divide them. Why this one addition means what? Multiply them. Okay, all right, so let's look at law number three. We have log x raised to the power of n base a is equals to, now this is a logarithm that has a power. Okay, this is a logarithm that has power. Now if a logarithm has power, all you need to do is bring the power to the back of the logarithm, so that will give us n log x base a. This is called power law. Okay, because it has power, it is called power law. So when a logarithm has power, all you need to do is bring the power back to the logarithm and use it to multiply the logarithm. So this n here, which is the power of x, is coming back to give you n log x base a. So the n will no longer appear here because it has come to the back of the logarithm, just like what we have here. So this law is called power law. Okay, let's look at number 4. Okay, if we have log a base a is equals to what? 1. The logarithm of a number to its own base is equals to 1. So look at this. This is a, the logarithm is a, the base is a. If they are the same thing, a or 10 or 9 whatever it is the logarithm is, and that is what you have as the base to, your answer is always 1. We call this logarithm of its own base. Logarithm of its own base. Okay, so log a base a is equals to 1. Okay, so our logarithm, in our laws of logarithm, number 4 says logarithm of its own base. That is, when a logarithm has the same value with its base, your answer is always 1. So let's assume I have log b base b, the answer will be 1. Log 10 base 10, the answer will be what? 1. So long as the logarithm and its base have the same value, your answer is 1. That's log number 4. Okay, so let's look at law number 5. Law number 5 says log x base a raised to the power of 2 is equals to, okay, now this is logarithm of x base a raised to the power of 2. Now if you check very well, it is the base that is carrying the power. In this law number 3, it was the log that was carrying the power. But here it is the base that is carrying the power. So if it is the base that is carrying your power, the answer will be the inverse of this base multiplied by the logarithm itself. So when you are bringing these two back of this logarithm, it will be inverse. So this will give us, inverse means 1 over. So since here is 2, we'll now have 1 over 2 log what? X base a. So we have removed this 2 and we have brought it back to the logarithm. But you will not bring it as 2, rather you bring it as inverse of 2, 1 over 2 log x base a. So the square will no longer appear because it has come back of the logarithm as inverse. Okay, so this is what we call power of the base law. Power of the base law. Okay, so let's go to law number 6. Law number 6 says that log 1 base a is equals to 0. Log 1 base a is equals to 0. Log 1 base a is equals to 0. This law is called logarithm of 1. Logarithm of 1. Okay, now this is telling you that so long as the logarithm is 1, whatever the base is, just know that your answer is 0. Okay, if you have log 1 base a, the answer is 0. If it is log 1 base b, 0. Log 1 base 10, 0. Whatever the base is, provided the log is 1, your answer is 0. That's what we call logarithm of 1. Okay, so let's take the last law, which is law number 7, and that law says log x base a is equals to 1 over log a base x. This law is called reciprocal law. Reciprocal law. Okay. This law is called reciprocal law. So this is the last law. It says log x base a is equals to 1 over log what? A base x. Now if you check very well, what is happening here is the logarithm and its base, they are being interchanged in this place. Okay, here is log x base a. For you to change it, for this x to be the base and this a to be the logarithm, you have to get the inverse of it, which is what? 1 over. So as you can see now, 1 over the log x, the x has turned to the base, which is what we have here, and the base, which is a, has turned to the logarithm itself, which is what we have here. So this law is called reciprocal law. That reciprocal means changing something, like turning something upside down. Okay, reciprocal, changing it. So these are the laws of logarithm that we have. So let me just go through it one more time. This is number one, says addition law. Addition law says that when you are adding two logarithms, provided their two base are the same, you multiply the logarithms. That's addition law. Then for subtraction law, when you are subtracting two logarithms, provided the two bases are the same, you divide the logarithms. That's for subtraction law. Then for power law, when a logarithm is raised to the power of any number, all you need to do is bring the number back of the logarithm and use it to multiply the logarithm. That is what we call power law. Then for number 4 is called logarithm of its own base. When you have a logarithm and the base is the same with the logarithm itself, your answer is always 1. Log a base a is 1. If it is log b base b, your answer will also be 1. If it is log 10 base 10, it will also be 1. That's what we call logarithm of its own base. The logarithm itself is the base, and when that happens, your result is always 1. And law number 5 is called power of the base law. Okay, in this case, it is the base that is having the power. So when the base is the one having the power, when you are bringing the power to the back of the logarithm, you take it as the inverse of it. As you can see, we are having, this is called log x base a raised to the power of 2. Now, this 2 that the base is carrying as the power, you have to bring it to the back of the logarithm. And when you're doing that, remember to write it as inverse. So it will be 1 over log x base a. So this is called power of the base law. And number 6 is called logarithm of 1. Whatever the base of the logarithm is, provided the logarithm is 1, your answer is 0. Log 1 base a is 0. Log 1 base b is 0. Log 1 base 10 is 0. So provided it is log 1, whatever the base is, your answer is always 0. And the last one is log x base a is equals to 1 over log a base x. This is called reciprocal law. It's like interchanging the logarithm and the base. As you can see here, this is log x base a. The x is the logarithm, the a is the base. But in this place, the a that is the base has become the logarithm, while the x that is the logarithm has become the base. So if that is going to happen, you must have your inverse, which is 1 over. So this is called reciprocal law. So these are the laws of logarithm that we have. So in our next, what we're going to do next is to solve some examples concerning these laws of logarithm. Okay, so let's continue. So we have example 1. So example 1 says log 4 plus log 25 base what? Base 10 base 10. Okay, log 4 plus log 25 base 10 base 10. Log 4 base 10 plus log 25 base 10. Now, this is a very good example of law number 1. Okay, this is a good example of law number one. And you remember law number one, which is called addition law. If the two logarithms have the same base, all you need to do is multiply the two numbers. Okay, so as you can see, this is base 10, this is base 10, so they are having the same base. Okay, so let's solve. So solution. So we are having log 4 base 10 plus log 25 base 10. Now this is 4 and this is 25. What are we going to do? We'll multiply 4 with what? 25 base 10. So that will give us log 4 times 25 base what? 10. Okay, so what is 4 times 25? 4 times 25 is 100. So that will give us log 100 base 10. Now you're not going to end your answer here because this is a big number. So we are going to find the index form of 100. What do I mean by index form? Now, anytime you are solving logarithm question, you always try as much as possible to have a logarithm that is the same with its base. Okay, you try as much as possible to have a logarithm that is the same with the base, and our base here is 10. So how can we make this number a number that is 10 is raised to the power? So for us to change this to index form, this is the same thing as what? Log 10 raised to the power of what? 2. 100 means 10 raised to the power of 2, which is 10 times 10. This 10 raised to the power of 2 means 10 times 10, which will give us what? 100. So we are changing this 100 to index form, which is 10 raised to the power of what? 2. So when we have our base is also 10 here. Now when you have something like this, remember from here now you refer back to logarithm of a number to its own base. We are now having log 10 base 10. But because of these two, we have to remove these two. This two also refers to law, power law, which says that when a logarithm is raised to the power of any number, bring the number to the back of the logarithm. So this is going to give us 2 log 10 base 10. Yes. So this 2 up here is coming back because that's what the power law says. So we have 2 log 10 base 10. So 2 log 10 base 10, remember logarithm of a number to its own base is equals to 1. So log 10 base 10 is 1. So this will give us 2 times the whole of this has turned to 1. So our final answer is 2. So log 4 base 10 plus log 25 base 10, the answer is 2. Okay, let's go through it one more time. This is log 4 base 10 plus log 25 base 10. This is called addition law. Now, addition law of logarithm says that when two logarithms are being added, so long as they are having the same base, all you need to do is multiply the two numbers. And that's what we did here. 4 times 25 to give us what? 100. Then this is base 10, this is base 10, so you take it as base 10. Now, after we've gotten your 100, this is a big number. We have to find the index form of this number. What will 10 be raised to give us 100? And that's 10 raised to the power of 2, because 10 times 10 is 100. Okay, so here it has taken us to what? Power law, which says when a logarithm is raised to the power of any number, use the number to multiply the logarithm at the back. So these two now will now bring it back of the logarithm. So we are now having 2 log 10 base 10. And this log 10 base 10 is also a law that says logarithm of its own base. And logarithm of its own base is equals to what? 1. So the whole of this log 10 base 10 has turned to 1. Multiplied by these two. 2 times 1, our answer is 2. Okay, so this is example 1. Now let's take example 2. Okay, example 2 says simplify log 12 base 3 minus log 4 base 3. Solution. Okay, so this is an example of law number 2, which is subtraction law. And subtraction law says that when you're subtracting two logarithms, so long as they are having the same base, what you do is you divide the numbers. Okay, so log 12 base 3 minus log 4 base 3, that will give us log 12 divided by 4 base 3. Yes, you remember that. This is subtraction law. In subtraction law, you divide. Okay, so 12 divided by 3 will give us what? Sorry, 12 divided by 4 will give us 3. So we have log 3 base what? 3. And this is taking us again back to another law which says logarithm of its own base. So log 3 base 3, the answer is what? 1. When a logarithm is the same with its base, your answer is always 1. So our answer in this question is 1. Okay, let's go through it one more time. I said simplify log 12 base 3 minus log 4 base 3. This is called subtraction law. And subtraction law says that if you are subtracting two logarithms, so long as the two logarithms are having the same base, as you can see, base 3, base 3, all you need to do is divide the two numbers. Okay, so that's what we have here. So we are dividing 12 by what? By 4. Then we have our log base 3, which is what you are seeing here, because they are the same. So you take it as what? 1. Then divide 12 divided by 4. And that's what we have here. So 12 divided by 4, that will give us 3. So we are now having log 3 base 3. This 3 is what? 12 divided by 4. That's this 3 you're seeing here. And this 3 is the what? The base. So when we have log 3 base 3, this is now taking us to another law which says that the logarithm of a number to its own base is equals to 1. So log 3 base 3, the answer is 1. So that's the answer for example 2. Okay, let's take example 3. Example 3. Evaluate log 27 base 3 plus 2 log 9 base 3 minus log 243 base 3. Okay, so solution. Okay, so if you check this question very well, you find out that we are having two laws inside this question. This is first of all addition law and this subtraction law. So we are combining law number 1 and law number 2 inside this question. Okay, so how do you solve something like this? It's very simple. So long as all of them are having base 3, base 3, base 3, you don't have anything to be afraid of. So what you do, you follow the normal procedure. But if you check very well too, there is a number at the back of this logarithm. So we are going to first of all remove this 2 from here so that it will be just normal log whatever that we have here base 3, like this one and this one. Because if you check very well, this is log 27 base 3. This is log 243 base 3. But in this middle one, there is a number at the back of the logarithm. So before we can solve, we are going to first of all remove this number so that everything will be in uniform before we can continue. Okay, so how do we remove that number? If you remember our power law, which says that, let me give you an example. The power law says that log x base n is log x raised to the power of n base a. That will give us, you bring this n back, it will be n log x base a. Now, what if you are giving it in this form? If it is in this form, you can also convert it back to this form, just like what we have here. So if we have 2 log 9 base 3, that is the same thing as you carry this 2, bring it to the up of this 9. That will give us what? Log 9 raised to the power of 2 base 3. As I believe you can compare what is going on here, okay? So if it is in this form, you can get it in this form. If it is in this form, you can convert it back to this form. That's exactly what is happening here. So bring these 2 to the front up of the 9 as the power of 9. Okay, so here we are carrying this 2 here, so it will now be log 9 raised to the power of 2 base 3. Okay, so let's start our solving. Okay, so this one remains log 27 base 3 plus, like I said, we are carrying this 2 to the power of 9. So that will give us log 9 raised to the power of 2 base 3 minus log 243 base 3. I believe we understand what is going on there. Okay, let's continue. So now we now have a straight logarithm. There is no number at the back of the logarithm of any of them anymore. This is just strictly log 27 base 3, log 9 raised to the power of 2 base 3, and log 243 base 3. Now we can't leave this number like this, rather we are going to multiply it. So 9 raised to the power of 2 means what? 9 times 9, and that will give us what? 81. So we are replacing this 9 raised to the power of 2 with what? 81. Okay, so that will give us log 27 base 3 plus log 81 base 3 minus log 243 base 3. Okay, so everything is now settled. This is the same log and base, log with the base. There is no power, there is no number at the back of the logarithm. So from here now, we can now apply our rule or our law. And the law says that addition says multiply, subtraction says divide. So this is going to give us, so long as this is base 3, base 3, base 3, so you take it as 1 log base 3. Then you have your bracket. This and this means what? Multiply them. So you have 27 times 81. Then subtraction means divide by what? 2, 4, 3. I believe you understand what I'm doing, okay? This is addition law. Addition law says multiply the two numbers, and that's what we did here. And this is what? Subtraction. Subtraction means divide. So that's what we divided with this number. Okay, so from here, let's continue. So we have 27 times 81. That will give us log 27 times 81 will give us 2187 divided by 243. Base what? Base 3. Okay. So when you multiply this, 27 times 81, you are having 2,187. Now when you divide this, 2,187 divided by 243, you are going to be having equals to log what? 9 base 3. Yes. When you divide this using your calculator, you will have 9. So this log base 3 is what we are having here. So what we have now is log 9 base 3. Now, just like what I said when we solved example 1, you can't leave this 9 like this because 9 is a number, is a perfect square. Let me say that. It's a perfect square. So what number will 9 be raised to? What number can 3 be raised to give us 9? And that number is what? 2. So this is the same thing as this 9. If we are to write it in index form, it will be what? 3 raised to the power of 2. Because 3 raised to the power of 2 means 3 times 3, which is what? 9. So we are replacing this 9 with 3 raised to the power of 2. So we are having log 3 raised to the power of 2 base 3. We have log 3 raised to the power of 2 base 3. I hope you know how we got the 3 raised to the power of 2. We change this to find the index form of 9. What 3 will be raised to give us 9. Just like what we did to 100 in example 1. How we turned 100 to 10 raised to the power of 2. Okay. Now, in this place, this is what we call power law. Power law says that bring the power to the back of the logarithm. Okay. And that will give us 2 log 3 base 3. Now, you still remember log 3 base 3 is what? 1. Logarithm of a number to its own base is what? 1. So we have 2 times. The whole of this log 3 base 3 has turned to 1. So we have 2 times 1, and our final answer is 2. All right, let's just go through it one more time. I said in this example 3 is a combination of law number 1 and law number 2. Okay, we have addition law here and we have subtraction law here. Now, all you need to do is follow your normal procedure. What we did first is to remove these two from here so that we have straight logarithm in all of them. And for us to remove these two from here, is going to come up to the 9 to give us 9 raised to the power of 2. And that's what we have here. And also, we can use this 9 raised to the power of 2 in this way. We have to get it as a whole number. And 9 raised to the power of 2 means 9 times 9, which is what? 81. So that's what we're having. This is the same thing. Log 27 base 3 is what we are seeing here. Then this 9 raised to the power of 2, I believe we'll still remember how we got the 9 raised to the power of 2. We carry these 2 at the back of the logarithm and put it here. Okay, so that's how we got this 9 raised to the power of 2. And 9 raised to the power of 2 means 9 times 9, which is what? 81. So this whole thing I've done to what? 81 log 81 base 3. And we have this log 243 base 3. So from here now, everything is having their log and their base. There is no power, there is no number at the back of the logarithm. So from here, we can now apply our law. Okay, and our law says that if it is addition, you multiply. If it is subtraction, you divide. So that's what we did here. So long as all of them are base 3 base 3 base 3, you take it as log base 3. Then 27 times 81, that's what you are seeing here. Because of this minus, you have your division 243. And that's exactly what we have here. So if you use your calculator, 27 times 81, that will give us 2,187. Divide by 243, 243, and that will give us what? 9. Now, when you have this 9, 9 is a perfect square number. So you find the index form of 9. And the index form of 9 is what? 3 raised to the power of 2. Because of this 3 here, our aim is to make its logarithm of its own base. Okay, so we have 3 raised to the power of 2 representing our 9. Then this has also given us back to what? Power law, which says that when a logarithm has a power, bring the power to the back of the logarithm. So these 2 will now come at the back here. That's what we are saying here. Okay, so we now have 2 log 3 base 3. And this log 3 base 3 is also another example of what? Laws of logarithm, which says logarithm of its own base. Log 3 base 3, if you remember example 2, we had something like this which gave us 1. So log 3 base 3 is what? 1. Multiply it by these 2. 2 times 1, our final answer is 2. All right, so if you check very well, inside this particular question, we have different laws playing inside here. Okay, here is a power law. Power law is here. When we got to this place, we have a logarithm of a number and its own base. Okay, and we have addition law, we have subtraction law. So you can see that about 4 laws of logarithm inside this particular question. All right, so that's all for example 3. Let's take one more example, which is example 4. Okay, so example 4 says that given given that log 2 is equals to 0.3010 and log 3 is equals to 0.4771, comma, find log 6. That's the question. Find log 6. Solution. Okay, so if you check this question, it's different from what we have been solving. This is a very different question, but these are the type of question you see in your WAEC or NECO. All right, now you find out that we are given the values of the logarithm already. So with these values of the logarithm, they already told you what to do. Okay, say log 2 is this, and log 3 is this. Now some students will be asking question, how did they get the value? Now I forgot to mention to you, maybe in our next topic we'll be using 4-figure table. In logarithm, we use what we call 4-figure table. If you check your 4-figure table, check logarithm of 2, you will see this value. 0.3010, and you check log 3, you also see this value inside your 4-figure table. Okay, What we are doing today is just the beginning of logarithm. By the time we start solving logarithm with table, you will find out that we'll be making use of our four-figure table. So it is from four-figure table, that's what we got, where they got these two values from. Okay, so they gave you the value of log 2 and they gave you the value of log 3, and they say you should find log 6. You will agree with me that there is a relationship between 6 and 2 and 3, because 2 times 3 will give you 6, right? So if we are looking for log 6, to have that log 6 is equals to what? Log 2 times 3. Yes, 2 times 3 is 6. Because the question already give you what 2 is, and it already gave you what 3 is. So that's to tell you that 2 times 3 will give you 6. So if log 6 is equals to log 2 times 3, then this log, use this log to multiply the two numbers, and it will have them separately. And that will give you log 2 plus what? Log 3. Now, you will ask the question, why did I change this multiplication to plus? That is where the laws of logarithm plays in. Remember, in law number 1, which says addition law, when you are adding two logarithms, you what? You multiply them. So if they are being multiplied, you do what? You add them. It's vice versa, okay? So log 2 times 3 is the same thing as log 2 plus log 3. Now, what is our log 2? Let's write it down, 0.3010 plus, what's our log 3? 0.4771. Okay, so let's add the two together. Now, students always have issue doing addition of decimal number, but you don't have to be afraid of that. This is simply 0.3010 plus 0.4771. So when we are adding, this is 0 plus 1 is 1, 1 plus 7 is 8, 0 plus 7 is 7, 3 plus 4 is 7.0. So our answer is 0.7781. So log 6, say therefore log 6 is equals to 0.7781. If you also check your four-figure table, you will see this value of log 6 as 0.7781. All right, so that is all for example 4. So this is a different example altogether when it comes to what? Logarithm. Okay, all right, so this is the end of example 4. Let's take assignments for today's class. Let's take assignments. All right, assignments. So we have question 1. Okay, say evaluate the following logarithms. Evaluate the following logarithms. Okay, number 1, we have log 2 base 10 plus log 7 base 10. Question 2, log 6 base 2 minus log 3 base 2. And question 3, 2 log 5 base 10 plus log 36 base 10 minus log 9 base 10. Okay, so if you check very well, this assignment number, question number 1 is talking about addition law. Question number 2 is talking about subtraction law. Then question number 3 is a combination of addition law and subtraction law. And we have done example on this. That's question number, example 3. Okay, so if you refer back to example 3, you should be able to solve this. Okay, so this is the end of today's class. Please try and solve this assignment and put it in the comment section, because anytime you solve assignment, it shows that you are learning, and it helps you to know if what you have been taught you followed up. So try to solve this assignment and put it in the comment section. We'll look into it. See you in our next video.